Let us try to solve more difficult examples concerning scalar product and work. For example number 1, using the figure in your screen, find the following. The x and y component of vectors a and b, the scalar product of the two vectors where vector a is 5 and vector b is 10, and the angle between the two vectors. Using the concepts and formula we have already discussed in the previous lectures, try to solve this. Okay, let us see if we have the same answer. The magnitude of vector A is 5. Vector B has a magnitude of 10. The angle between the x-axis and vector A is 45 degrees. The angle between the x-axis and vector B is 111 degrees. Let us try to solve first the x and y components of vectors A and B. We can use the following formula. A sub x is equal to A times cosine theta to find the x component of vector A, and A sub y is equal to A sine theta for y component of vector y, or vector A. If you cannot remember this, we can look back in Module 2 of this course. We will use the same formula to get the x and y components of vector B. Let us solve this by substituting the values. And finally, using your scientific calculator, we will get the following results. X component of vector A is 3.54. Y component of vector A is 3.54. X component of vector B is negative 3.58, and its y component is 9.34. By default, even in your examinations, we will round this off to the nearest hundreds. Now that we got the x and y components of vectors A and B, we can solve the scalar product using the formula A times B is equal to A sub x times B sub x plus A sub y, B sub y. We then substitute the values as this, solve as indicated in the operation, and finally, we will get the scalar dot product of 20.39. To solve for problem 3, which asks to calculate the angle between the two vectors, first, we will use the formula theta is equal to arc cosine multiplied by our dot scalar product over product of vector A and B. Let us substitute the values as this and perform the indicated operation. You can simply input these values in your scientific calculator, which when you press enter, you will come up with 65.93 degrees. And these, class, are our final answers. Let us have another example. This time, let's solve work-related problems. Try to determine the work done by Eric if the luggage bag with 10 kg is pulled for 45 meters vertically with an angle of 35 degrees. Again, let me pause this video to give you a chance to answer this by yourself. Okay, let us solve this now. In this problem, you are asked to determine the work done by the force acting on the system. The given values are displacement, which is 45 meters, mass, which is 10 kilograms, and angle, which is 35 degrees. Before calculating the work, force should be determined first using our formula F is equal to mg, where mass is 10 kilograms and g is negative 9.8 meters per second square. We will multiply these two values and we will get negative 98 newtons. Next, we will substitute these values in our formula. Negative 98 newtons times 45 meters times cosine 35 degrees. Performing the indicated operations, we will get negative 3,612.46 newtons meter, which is the work done by the Earth on the luggage bag. In the next lesson, As we go deeper in establishing the relationships between work, energy, and power in this module, we will talk about conservative and non-conservative forces that act on moving bodies that generate work. That is all for this lesson. I am Gilmer De Castro, and see you in the next video.